Welcome back, students. Now we will discuss about subtraction in Turing machine. Subtraction using Turing machine or subtraction in Turing machine. So subtraction in the sense, so we will be comparing the two numbers and the common or the subsets of the numbers will be eliminated. For example, if you are having 2 minus 1, 1 is subtracted from 2 means you will be having remaining 1. So how it can be mentioned in binary format is, so this 2 can be represented as 2 zeros and 1 will be represented as 1 0 and the minus will be represented as hash. This hash will be acting as an intermediate and left hand side on blank will be the right hand side, not one blank. So as per the tape, so we will be representing only one blank in order to indicate the left end of the input, and on the right hand side we have mentioned one blank to indicate the right end of the input. Okay, so the output should be only 1 0. So what I'm going to do is, so the pointer will be starting here. The head pointer of the Turing machine will be starting here. So 0 will be replaced as blank and move to right hand side until you reach the this right hand blank. Okay, in order to ensure that input has been completed. So in the left hand side 1 0 has been replaced as blank and we are moving to right hand side. Mention this 0 as it is and move to right hand side. Then this hash as it is and move to right hand side, and this 0 as it is and move to right hand side. Finally, we will be getting blank. After reaching the blank, again move to the left hand side. Now this 0 will be again replaced as blank. So why it is again replaced as blank means, so for this left hand side 0, we have to cross one right hand side 0 to make the input performance equivalent. Okay, so this 0 will be replaced as blank and move to the left hand side until you reach the left hand blank. Okay, 0 blank. Now the pointer will be here. Okay, so now again move to the right end. This 0 will be replaced with blank and move to right hand side until you are reaching the blank. Hash will be mentioned as it is and moving to the right hand side. You will be reaching the right hand blank here. So after reaching this blank, again move to the left hand. So this blank is mentioned for understanding purpose. This after reaching this blank, again move to the left hand. Now this hash will be replaced as 0 and move to the left hand until you reach the blank. Okay. Now you see here only 1 0 is available. That is the output. Okay. So how can we draw the Turing machine? How can we draw the automata diagram for this Turing machine? So start from the initial state Q0. So 0 will be replaced as black and move to right hand side, and so until you are reaching the right hand blank, you have to mention that 0 is replaced as 0 and move to right hand side, and hash will be mentioned as hash and move to right hand side, then Q2. Okay, you can see here after reaching the right hand blank, again we have to move to the left hand. After moving the left hand, this 0 will be mentioned as blank. So mention it as with Q3. This 0 will be mentioned as blank and again move to left end, you will be having hash 0 and R. So until you are reaching the left end blank, you have to mention as it is. Blank is mentioned as blank. So sorry, here it is not blank, it should be mentioned as hash. Hash is mentioned as hash and move to left end. Now, at one point, you will be reaching the blank again. So, blank will be mentioned as blank and move to right hand side. Okay. Again, this 0 will be there. Same operation will be continued. 0 will be mentioned as 0. Sorry, blank and moving. 0 will be replaced with blank and moving to the right hand side. Then hash will be there. Hash will be mentioned as hash and moving to the right hand side. Now again you will be having a blank. Blank will be mentioned as blank and move to the left hand side. Now the input will be staying in the state, that is Q2. So from Q2, we don't have any other states. Okay. So we are having hash. So what we are going to do is just make the state as an acceptance state. Q3. Draw this diagram like this. Then this hash will be replaced as 0 and move to left hand side. So you will be either you can move to the left hand side, you will be having blank, or you can stay halt here. Okay. So this is what the final output. So actually, this is called, this is X and this is Y. So this subtraction mentions about X greater than Y. X greater than or equal to Y. Okay. Now we will go for another one example. For example, 1 minus 1. Okay. 1 minus 1 equal to 0. So 1 minus 1 equal to 0 means, so you will be having 1 0 black and hash will be the separator and this one will be having 1 0. So here the black will be there. So what we are going to do, this 0 will be replaced as black and move to right hand side until you are reaching the blank the right hand side. While moving to the left hand, this 0 will be replaced as blank and you have to move to the left hand side. So after moving to the left hand side until you are reaching the blank, you should not change the inputs, just move to the left hand side until you are reaching the blank. After reaching the blank, again move to the right hand side. So now we are in this state. Now we are in this state. Okay. So blank is replaced as blank and moving to the right hand side. We are in the state of Q0. So from Q0, only the state transition will be occurring for the input 0. There is no transition for hash. What we are going to do is just draw another one state as Q4 and mention it as hash. Okay, hash is replaced with hash and move to right hand side. Now you will be having blanks. Okay. So again, you can join this. Blank is mentioned as blank and stay put. Okay. So this automata works fine for both x greater than y and x greater than or equal to x equal to y. Okay. So I hope you can understand the subtraction performance in Turing machine. Thank you.